All right, so this is recording. I'm recording on a Mac this time, and I'm at the library. Anyway, this is the directions on how to do the linear sorting and matching worksheet. There's a lot of instructions, so I thought it'd probably be a good idea to just show you how to do graph A. I gave you the answers to it, but that may not be enough. So when you're looking at graph A, let's see if I can't move this. Graph A, this is going to give you enough information to at least get started. Graph A moves down. Any line that moves from left to right down, like a ski slope, has a negative slope. B over here next to it goes up, so it has a positive slope. That's pretty obvious, but actually that's helpful because something with a negative slope, when you calculate slope, has to come out as a negative number. So if you don't have a negative number when you calculate the slope for this line, then you made a mistake. But anyway, first things first. When you're looking to figure out, let's go back up here. What we're trying to do is figure out the equation for that line on graph A. So to do that, and I'll show you down here, we're going to be picking from these choices, and we'll get to trying to understand these choices later. But right now we can build an equation, not even looking at those choices, using the information in this picture. So the first thing we're going to do that is, let's pull up this document. Is it going to work? No. There it is. All right. So we're going to find the equation of a line that's drawn on a graph. This is the equation we have to make. Y equals mx plus b, which you may have already run into with your homework. The equation of a line. So where at y is just the output, x is the input, m is the slope, and b is the y-intercept. The y-intercept, what that means, it's where the line crosses the y-axis. I'll show you what that means. This point right here, where this blue line is crossing the black y-axis, that line that's always there on every graph, where that line crosses is a point, and that point is the y-intercept. Y-intercept is not and can't be this y in the equation. It's not this y. That y is the output. That y changes. The y-intercept b never changes. It's always just where the line crosses the y-axis, right there. And of course we have another place where the line crosses the x-axis, so you might guess that little point right there becomes the x-intercept. In any case, this y-intercept is a point. And if you know from your graphing, don't forget that when we find a point on the line, we're going a certain distance x, and then up or down a certain distance y, and that gives us a point on the line. So the point is defined by an x value. We have to go to this x line and see, well, what x is it? Well, it's 0, because it's in the middle. You can't have a point on the y-axis if the x is not 0. If x was 1, the point would be too far over. If it was -1, it would be too far over. It has to be 0. So x will always be 0 at the y-intercept. So our point, x will always be 0 at that point. So the point of the y-intercept from our graph is going to start with a 0 for x, and the point that is y is, let's look at that, 1, 2, 3. It's 3. So our point for the y-intercept is 0, 3. But we're not going to put in a point into our equation. B is not 0, 3. For the equation, they just use 3 because the y-intercept is 3. I know it sounds crazy. I just went to all this trouble to tell you it's a point, but the value that we take away from that point is just 3. So our B equals 3, which equals the y-intercept. Let me think about this. Where should I put it? Equals 3. So we have a value now for B. Slowly we're going to plug in the rest, not all of these values, just slope is next. To find the equation of a line, all we need to do is find the y-intercept, which is B, and then find the slope. Talk about how you can figure out slope just by looking at the graph. So slope is rise over run. I should write that down. What that means is when you look at a graph of the line, the distance you went vertically, whether up or down, and you're looking to make a triangle basically. So it looks like here, and I wish I could blow this up bigger. If I went up one square and then over to the right, so that's our left, minus 2, so up 1, over 2 to the left, I would reach the line again. If I went up 1, over 2, I'd reach the line again. And you can keep making this pattern, up 1, over 2. So what that means is your rise over run is up 1, rise 1, and the run is negative 2. So then in our case we would have our rise over run. Right? So our rise over run, remember we were going up 1, so that's our rise. And then we were going over to the left 2, so that's negative 2. Okay. So our slope then is 1 over negative 2, or negative 1/2. And now let's look at another way you can see that. Another way to look for the slope is you could also be going down 1 and over to the right 2. Negative 1, positive 2, negative 1 down, positive 2 over. And you keep hitting the line again. Negative 1, positive 2 over. And that comes out the same number. So if I were to do that, then the rise over the run would be, what did I say? I said down 1, that would be negative 1. And then I went over to the right, which is positive 2. Okay, well that's still a negative 1/2. Whether you have the negative on the 1 or the negative on the 2, it's still a negative 1/2. So we do have a slope of negative 1/2. But that's fast and easy, but we have a line that's easy to do. However, if we have to calculate slope, we have to use this equation here, and we do that by using points on the graph. Alright, so let's take a look at how we can do that. If I were to move this, we're going to use our equation y2 minus y1, which is, what the heck does that mean? Okay, we find points on the graph. Well, any point on the graph, if you're finding points on a graph, you look at the line where the line crosses, not in the middle of a square, but at the corner of a square. That's the easiest points to pick. You don't want to pick a point in the middle of a square. That's going to be a fraction or a decimal. So if we're going to pick points along this line, let's look. Okay, it intersects here, which is over 1, 2, 3, 4. Is that 4? 1, 2, 3, 4, and then it's up 1. So a point of x is 4, y is 1. Okay. X was 4, because we went over to the right 4. And we had a y of 1. That's a point on the graph, right? Well, we also know another point on the graph that we already figured out, and it's a really easy point to grab, and that's the y-intercept. So we know that x is 0 at the y-intercept, and it was 3. So let's use that point, make our lives easier. Let's say our next point then is x is 0, because we're talking about the y-intercept. And that was 3, if you remember correctly. And I could move this so we could see that. If I move this up, that's what we discovered our y-intercept was, 0, 3. So we're using 2 points. But now we have to use this equation, y2 minus y1. Well, what does that mean? What that means is, here's a point, x, first point, and it doesn't matter which one you call the first point. It doesn't matter at all. And the y, these are the x and y of the first point. x1, y1. Okay, so this point is x1, this point is y1. This point is x2, because it's the second point. So it's the x value of the second point. And this one is y2. So y2. So we take our equation, y2 minus y1, and what that means is, let's see, I can't move this into the same screen here. What that means is, this is y2, so that goes there, 3. This is y1 over here, so that goes here, that's 1. So the, up on top is 3 minus 1. So we have, let's put it here, 3 minus 1. And then this is x2, 0. So there's x2, so we have 0 minus, and then x1 over here is 4. And when we work that out, we get 3 minus 1, which is 2, over 0 minus 4, which is minus 4, and this reduces to our ever so wonderful negative 1/2. Negative 1, I'm running out of room, half. So our slope, whether we calculate it using points or just looking at the graph, looking at the rise over the run, we get a slope of negative 1/2. Now we put that back into our equation. I'm trying to keep this a short video, so I'm going to have to make another one to go on with this. But right now, let's plug in m now is negative 1/2. So we actually have the equation of our line, which is, because we don't need to fill in the y and the x for the equation, the y and the x remain blank, because you can plug values in for those, the input and the output, as you've been doing with other problems. So our equation for this line is y negative 1/2 x plus 3, because I just simply plugged in plus 3, because what I did was I plugged in values for b and m, so that's the equation of the line. Now the problem here is, and I have to do another video to show you what we're dealing with, is that our choices for equations don't always start with y. Some of them have 2x minus y, 3x minus y equal negative 2. So I have to show you in the next video, well, how do we begin to look for our equation when our equation is negative 1/2 x plus 3.